students. Today I want to tell you about expression for effective capacitance of two capacitors in series connection. So first of all, what are capacitors? Anybody? Capacitors are the devices which can store electrical energy. So to use the capacitors in an experiment or for any practical purpose, we go for choose or select any one of the combination. So this concept is combination of capacitors. So there are two ways how the capacitors can be used together. Two or three capacitors are used together. So when you are taking two capacitors for any use, those two capacitors can be connected in parallel or in series. So series or parallel combination of capacitors. So today you are learning combination of capacitors in a series connection, in a series. So the concept name is expression for effective capacitance of two capacitors connected in series. So see, series parallel combination. So when you say two capacitors are in a series combination and two capacitors are in a parallel combination means when the two capacitors are connected from one end to another end in a straight line. See here, see this diagram. Here the capacitors are connected in a straight line direction and they are connected from one end to another end. Here first end is connected, see second end is connected to first end. The negative terminal of capacitor here, see it is connected to positive terminal. So end to end connection. I am using two capacitors in this diagram. So the first capacitor is having capacitance C1 and the second capacitor is having capacitance C2. So what are C1 and C2? C1 and C2 are not capacitors. C1 means capacitance of first capacitor. C2 means capacitance of second capacitor. So now this diagram represents series combination of two capacitors where C1 and C2 are their capacitances and plus Q minus Q charge on each capacitor. See, first capacitor has positive charge, negative charge. Second capacitor has same positive charge, same negative charge. So here see, for series combination of two capacitors, conditions, there are two conditions are there. First condition, their charges must be same. If there are two capacitors, the two capacitors must have the same charge on each plate. So same charge means here positive, how much positive charge is present? The same positive charge must be here. How much negative charge is present? Same negative charge must be here. So same charge is present for each capacitors. This is the first condition. Yes, remember what is the condition for a series combination of two capacitors? First one is charge must be same. Second one, here charge means Q. It must be same. See, I am not taking Q1, Q2 here. Q1, Q2 plus Q1 plus Q2 plus minus Q1 minus. I am not taking like that because here charges are same. Why I am not taking Q1, Q2 for this case? Because electric charges are same for the given two capacitors, right? Second condition, potential, electric potential is different for different capacitors. The first capacitor has electric potential V1, second capacitor has potential difference V2. First capacitor has potential difference V1, second capacitor has potential difference V2. Electric potential, right? So, and one more thing, what is the total potential difference for the series combination? The total potential difference for the series combination is it is equal to sum of the potential differences across each capacitors. That is V. V means total potential of the combination. It is always equal to sum of the potentials of the two capacitors. That is V equals to V1 plus V2. This only I am taking as the first equation. So for series combination, here V equals to V1 plus V2. So you see, use the definition of capacitance. Formula for capacitance is C equals to Q by V. You learned in last class C equals to Q by V. So and you see here equation number 1 has V1, V2. So I want to arrange this formula in terms of V equals to something. So you bring V here, C, and carry C to the denominator, it becomes V equals to Q by C. Yes, V equals to Q by C. So now as there are two capacitors, for first capacitor V1 equals to Q by C1. For first capacitor V1 equals to Q by C1. For first capacitor means this one. For second capacitor V2 equals to, see, from this one I derived this formula V equals to, I brought V here and C here, V equals to Q by C. So for first capacitor potential is V1, capacitance is C1, charge is Q. For second capacitor potential is V2, charge is Q, minus Q ಅಂತ ತಗೊಳ್ಳಲ್ಲ, Q ಅಷ್ಟೇ, Q ಅಂತಾನೆ ತಗೋಬೇಕು, minus Q plus Q ಅದರ ಮೇಲೆ ಇರುತ್ತೆ ಚಾರ್ಜಸ್. But for derivation purpose you select only Q as the charge on each capacitor, right? So see here, that's why I selected let I took Q be the charge on each capacitor. So here for first capacitor V1 equals to Q by C1. For second capacitor V2 equals to Q by C2. So substitute the values of V1 and V2 in equation number 1. Equation number 1 becomes V equals to V1 is Q by C1 plus V2 is Q by C2. Bring Q outside as it is common in both the terms. So V equals to Q into 1 by C1 plus 1 by C2. 1 by C1 plus 1 by C2. Equation number 2 it is. Equation number 2 it is. So now you think instead of taking two capacitors, if we want to take only one capacitor which is having capacitance equal to two capacitors in series. See, now I am taking a capacitor of capacitance CS. This is the capacitor of capacitance CS. CS here, CS means equivalent capacitance of capacitors in series. CS ಗೆ ನಾವು equivalent ಅಥವಾ effective capacitance. CS is effective capacitance of two capacitors connected in series. So what does the meaning of effective capacitance? If you see, instead of two persons, if only one person can perform the work equal to two persons. See, ಇಬ್ಬರು ಮಾಡುವಂತ ಕೆಲಸವನ್ನ ಒಬ್ಬ ವ್ಯಕ್ತಿ ಮಾಡ್ತಾ ಇದ್ದಾನಂದ್ರೆ ಆ ವ್ಯಕ್ತಿಯಿಂದ ನಾವೇನು ತಗೋಬಹುದು, ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಅಂತ ತಗೋಬಹುದು. ಈಗ ಎರಡು ಕೆಪಾಸಿಟರ್ಸ್ ಇದಾವೆ, C1 C2 ಅಂತ ಎರಡು ಕೆಪಾಸಿಟರ್ಸ್ ಇದಾವೆ. ಆ ಎರಡು ಕೆಪಾಸಿಟೆನ್ಸ್ ಸೀರೀಸ್ ನಲ್ಲಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಷ್ಟು ಕೆಪಾಸಿಟೆನ್ಸ್ ನ ಒಂದೇ ಕೆಪಾಸಿಟರ್ ಕೊಡ್ತಾ ಇದ್ರೆ, then the capacitance of that single capacitor is called as effective capacitance. And it is see for series CS, series ಗೆ C to the base S, C to the base S, series ಗೆ ಇಲ್ಲಿ ಅದೇ CS ಅಂತ ಇದೆ. Parallel ಗೆ CP, parallel ಗೆ C to the base P, series ಗೆ C to the base S, right? You see what I am telling is effective capacitance of two capacitors in series is the single capacitor having capacitance equal to capacitances of two capacitors combined in series or parallel. That capacitance is called effective capacitance. So here effective capacitance is the single capacitor. It is the capacitance of a single capacitor whose effect or which can give the effect equal to combination of two capacitors in the series or in parallel. That a single capacitor having capacitance Cs, that is called effective capacitor. So for Cs is the equivalent capacitance of the capacitors connected in series. Cs ಅನ್ನೋದು equivalent ಅಥವಾ effective equivalent ಅಂದ್ರೂ ಒಂದೇ effective ಅಂದ್ರೂ ಒಂದೇ, right? Equivalent capacitance of the capacitors connected in series. Then V equals to Q by Cs. Thus this formula becomes V equals to Q by Cs. So for the single capacitor, here the charge is same Q and capacitance is Cs. So V equals to Q by Cs. Now you compare 2 and 3, this equation and this equation. Comparing 2 and 3, LHS is same. LHS is V here LHS is V. So RHS can be equated together. RHS Q by CS equals to Q into 1 by C1 plus 1 by C2. Q cancels. So after 1 by CS equals to 1 by C1 plus 1 by C2. 1 by CS equals to 1 by C1 plus 1 by C2. So 1 by CS equals to, this is the expression. This is one formula. This is the formula for effective capacitance of two capacitors in series. Okay, up to this you can write up to this only. After that, see here, if you want to simplify the equation, here expression for series combination means 1 by Cs equals to 1 by C1 plus 1 by C2. So if you want to simplify further, then take the LCM here. LCM is C1 into C2. So C2 ಇಲ್ಲಿ C2 C1. 1 by Cs equal to C2 plus C1 divided by C1 C2. LCM ತಗೊಂಡಿದ್ದೀನಿ. C1 ಇದೆ, C2 ಬರಬೇಕು. C2 ಇದೆ, C1 ಬರಬೇಕು. ಪ್ಲಸ್ ಮಾಡಿ divided by C1 into C2. So 1 by Cs ನ Cs ಅಂತ ಬರೆದ್ರೆ reciprocal value ತಗೋಬಹುದು. Reciprocal value. So this is the shortest formula for combination and it is also a best formula for the calculation. So effective capacitance of ಇಲ್ಲಿ ನೀವು 1 by Cs ಅಂತ ಬರೆದು effective capacitance ಕಂಡುಹಿಡಿಯಿರಿ. ಸೀರೀಸ್ ನಲ್ಲಿ ಇದಾವೆ ಎರಡು ಕೆಪಾಸಿಟರ್ಸ್ ಅಂತ ಕೊಟ್ಟಾಗ ನೀವು ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಓಕೆ ಯೂಸ್ ಮಾಡಬಹುದು, ಇಲ್ಲ ಅಂತಲ್ಲ. ಬಟ್ ಯೂಸ್ ಮಾಡಿದಾಗ ಫೈನಲ್ ಆಗಿ 1 by Cs ವ್ಯಾಲ್ಯೂ ಬಂದಿರ್ತದ, ಅದನ್ನೇ ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಚ್ಚಿದ್ರೆ ದಟ್ ಗೋಸ್ ರಾಂಗ್. ನ್ಯೂಮರಿಕಲ್ ಏನಾಗ್ತದೆ ಅಲ್ಲಿ ಫೈನಲ್ ಆನ್ಸರ್ ರಾಂಗ್ ಆಗ್ತದೆ. Cs is the answer. Cs ಅಂದ್ರೆ effective capacitance ಅಥವಾ equivalent capacitance of two capacitors in the series. So Cs ಬರಬೇಕಾದ್ರೆ Cs equals to formula C1 into C2 divided by C1 plus C2. C1 plus C2. Right? Yes, what is the formula for series combination of two capacitors? This one and this one. There are two formulas. One formula is written in two ways. 1 by Cs equals to 1 by C1 plus 1 by C2. Or Cs equals to C1 C2 divided by C1 plus C2. Right? So consider two capacitors whose capacitance is C1 and C2. Let Q be the charge on each capacitors. Let V1, V2 be the potential differences across C1 and C2 respectively. Yes, as I told you, for series combination, charge is the same. First thing, charge must be same on each capacitor. Second, potential different, but total potential is equal to sum of two potentials. Therefore, V equals to V1 plus V2. The basic formula. Use the formula of capacitance. C equals to Q by V. So V equals to Q by C. For first capacitor, V1 is Q by C1. For second capacitor, V2 equals to Q by C2. Adding, equation number 1 becomes V1 ಜಾಗದಲ್ಲಿ V2 ಜಾಗದಲ್ಲಿ. So V equals to Q by C1 plus Q by C2. V equals to Q into 1 by C1 plus 1 by C2. Say here Q is the common one. So instead of two capacitors, if there is only one capacitor whose capacitance is Cs, and its effect is equal to the sum of two capacitances, then that Cs is called equivalent or effective capacitance. So then for effective capacitance, potential is V equals to Q by Cs. Compare 2 and 3. Comparing 2 and 3, what you will get? Q by Cs equals to Q into 1 by C1 plus 1 by C2. Q cancels here. 1 by Cs equals to 1 by C1 plus 1 by C2. So simplifying, you will get another form. Cs equals to C1 into C2 divided by C1 plus C2. This is about effective capacitance of two capacitors connected in series. In next class, I am going to tell about parallel combination. Okay, say watch this video for 2 times. Definitely you will understand, right? You will come to know about the series combination. If you are still having any doubts, means you can message to my personal numbers. Okay, have a nice day.